Welcome to the second video of the Structures and Forces unit. This is topic 2, mass and force. So 2 major essential questions you're going to have answered by the end is, can you recognize and use units of force and mass? And then can you identify and measure the forces and the loads? So lots of key terms. Most of them, those first 3, have to do with how we're going to measure. We talk about balance and force. We talk about newtons, which is another unit. Talk about gravitational force and weight, the force meter and the diagram, magnitude, dead load, and a live load. So the first thing I want to talk about is mass. So we need to remember that everything is made up of tiny little particles. So the more particles that make up an object, the more mass it has. So when we're measuring mass, we use what's called a balance. And so this is a picture of a balance you might have seen in the lab before, kind of similar to the balance you might see at a doctor's office when they move the measuring over and they try to measure you. So when we're talking about mass, we use the base measurement of grams. So if something's a larger mass like us, we'd use kilograms, which is 1 kilogram is equal to 1,000 grams. If something's really small, we might use a milligram, which means 0.001 grams. So it's really little, whereas a kilogram is bigger. We're going to be dealing mostly in kilograms in this unit because everything we're talking about is a larger mass. So you might have heard the word weight before. And so lots of times when we get to grade 7, we start to understand the difference between mass and weight. And even though they've been used interchangeably to maybe describe how heavy you are, so what's your weight? And you tell somebody you're this many kilograms or this many pounds. In science, it means something different. So mass is, like I said, the number of particles that makes up. The more you have, the more mass you have. Whereas weight has to do with how much gravitational force is placed upon you. So mass stays the same no matter where you're located, whether you're on the moon or whether you're on Earth. And it is not always the same as an object's weight. So you can see that this little person is standing on Earth and their weight on Earth is about 560 newtons. Their weight on the moon is around 90 newtons, but their mass is always 56 kilograms. So we're going to talk about force. And I've already said the word newtons a few times. So that's the unit you use when you're talking about force. 1 newton is the amount of force needed to hold up about 100 grams. So when we talk about holding up 100 grams on Earth, you need about 1 newton of force to hold that up. Types of forces include external forces. So someone might call that the load, or you can hear someone call it an internal force. You could have a static force, which is a dead load, or a dead, like meaning it doesn't move. And you can have a dynamic load, which is like a live load, a moving amount of force. And then you also have a gravitational force. And that is the same as talking about someone's weight, not their mass, their weight in science. The effect of a force on a structure is going to depend on a few things. So the amount of the force, which is the magnitude. So how much force is put on something. The direction the force is put on the object, the location of where the force is applied, and the overall strength and stability of the structure. So you can see this guy in the picture is trying to move this fridge. That's what that is a refrigerator. So we don't actually know how much force he's applying. He looks like he's got quite a bit of force because of the look on his face and the way his body is put. You can see that the direction of his force is in the direction of that arrow. So it's the force diagram showing he's pushing it that direction. You can see that the location that a force is applied is halfway up the refrigerator. And then we are going to assume that the fridge is pretty strong and stable of a structure. So depending on all 4 of those things will depend on whether that actually, there's anything that happens because of the force he's applied. So 2 types of forces that I talked about that we're going to look at more detail in topic 3 are external forces. So from the outside of a structure, wind, waves, a person, gravity. And then internal forces are what push back and is offered to keep the structure's shape. So you can see in the picture below, you can see the external forces, that big arrow. And then within that block, let's call it a brick, you can see that there's internal forces pushing back. External forces stay the same for long periods of time. Some of the external forces are static or dead forces or load. That's the weight of a structure and its non-moving load it supports. So this stays the same for a long period of time. A dynamic load is an external force that moves or changes with time. So it can change really quickly and it will change over time. So remember, a dead load, meaning it's dead, it doesn't move, and a live load, meaning it moves. Static, doesn't move, dynamic moves. So when you take a look at this picture, it's asking you what the static and the dynamic loads would be. So you have to remember, if dynamic loads means the things that are moving. So for the truck and the car, they're both putting pressure or force as they move along the bridge. The bridge itself is putting force back on the trucks and it's staying the same. So the dynamic is the moving truck and the moving car, and the static load is the bridge putting back on the vehicles. When we talk about gravitational force, we already kind of talked about weight. So it's the same picture again. This is just how much force is gravity. So on Earth, for that person to stay on the Earth's surface, there's about 560 newtons of force from gravity pushing it down. Whereas the moon, it's about 90. When we measure force, we can use what's called a force meter or a spring scale. And if we were in school, I would actually pull one of these out. That's what it looks like, the ones we have in our lab. And it's the most common instrument we use for measuring forces in the lab. A force diagram is the way that we can show the strength and the direction of the forces. So you can see the mountain climber. And what we can do is we can use arrows and we can show the different forces. So we have the force of the rope pulling him up. We have the pull of gravity pulling him down. We have him pushing off the cliff, and we have the cliff pushing back on him. So just to review, mass is the measure of the amount of the material in an object. Weight is the gravitational force acting on the body. Force is the measure of the interaction between the two bodies. And load is just another word for force exerted on the surface of the body. So the two pictures I've showed you on this slide show you where I would consider the force, where the mass would be, where the load would be, and where the weight would be. So you can see the guy sitting on the chair, and you have, this is like a pulley system with a mass on it. So at the end of this one, lots of theory and laws. Can you recognize and use units of force and mass? So remember, when we talk about force, we're talking about newtons. And I can measure them with a spring scale, and I can draw a force diagram to show them. And then when we're talking about mass, we're talking about how many particles make something up. And we're talking about grams. We're talking about kilograms. We're talking about milligrams. And we use a balance to measure that. And then the other thing you have to be able to do is, can I identify when it's talking about a static load versus a dynamic load? So the dead versus the live. Can I figure out when they're talking about internal or external? And can I recognize when there's gravitational force?